जाने की संभव
अमोल, जो बच्चा भैया के लिए तैयार कॉलेज में अभी गेट पे जैसे
वो मेरे पिया गए रंगून किया है वहाँ से टेलीफोन तुम्हारी याद सताती है तुम्हारी याद
Every day, a ritual takes place in Janki's kitchen. Radio waves cause disturbance in the radio, and Janki bursts out on Mr. Patel, believing that he doesn't get the radio fixed.
तुम्हारी याद सताती है
The running motor in the mixer causes spark that produces radio waves. These waves interfere with the radio signal received from the radio station. These invisible waves are at work all around us, carrying and delivering messages, information, and also bringing secrets from the vast yet hidden universe. The discovery of these waves is also the story of human mind, its spirit to explore new frontiers and ask new questions. A British scientist, James Clerk Maxwell, attempts to combine two natural forces, electricity and magnetism. Mathematics gives him an incredible insight into nature's working, that light is nothing but a manifestation of the phenomenon of electric and magnetic fields dancing together mutually perpendicular to each other. Maxwell also predicts that these electromagnetic waves could come in a wide variety of frequencies and wavelengths, some of which may be visible and some may be invisible. The question was how to detect them.
Riddles are the essence of science. Anyone who does science is a person who loves solving puzzles. And nature presents puzzles to human beings. I see light. Is there anything which I cannot see, but it is also like light? Anybody would try to understand that. That's the big riddle. That's the riddle with which radio waves started.
Maxwell leaves only one indication, that flowing current may give birth to these waves, and they themselves are capable of generating current in conductors. A young German scientist, Heinrich Hertz, decides to explore the mystery of these Maxwellian waves. Physicist Sudakshana Kundu will recreate Hertz's experiment in a slightly different fashion. She will generate 16,000 volts of current and will feed it to a spark gap made up of two wires.
It's so simple to generate an electric spark. I'm feeding high voltage to a pair of wires, and as I bring the wires closer, just watch me.
Normally, air resists the flow of current from the tip of one wire to another. As they come closer, the current breaches the resistance and there flows a beautiful spark. The crackling sound announces the arrival of these waves at the radio. Thus, the radio becomes an alternative eye to see these invisible waves.
There must be something other than the light that is coming out. It is an invisible thing which we cannot see with our eyes, but the transistor can see it for us. This is, in principle, what Hertz exactly did many years ago. What you've just seen took us only a few hours to assemble, but things were not so simple for Hertz then. The technology was not available in his time. He had to learn how to generate the voltage and the spark. He was not even sure if the spark had a wave with it.
Hertz had discovered the waves in a similar fashion. His setup had a coil to generate high voltage, a spark gap, big reflectors to focus waves into a beam, and another conductor ring with a spark gap, kept at a distance. The idea was that if a spark produces invisible waves, they would travel and create a current in the smaller conductor ring, eventually generating a tiny spark in the gap. Speculation and insights are an integral part of science. After many attempts, Hertz was able to see a tiny spark at the other end, proving the existence of these waves. The progress of science has been so fast that today the historic event has become a part of Janaki and Sudakshana's daily lives. With the discovery came other questions. Could these waves travel far in space? Is there a simpler way to detect them? A prolific British scientist, Sir Oliver Lodge, finds that a glass tube filled with iron filings can work as a detector of electromagnetic waves. In the presence of invisible waves, the filings align themselves and current flows in them. A flicker of the galvanometer needle announces the generation of current. An unknown physicist, Jagdish Chandra Bose, while teaching in Calcutta, reads a book on Hertz and gets caught in the grip of these magical waves.
The work of Bose followed that of Hertz by a very short period of time. So this shows the alertness of a scientist in picking up something exciting and being able to reproduce it in his own lab. But actually he did not reproduce it. He created something new, the science of millimeter waves. And that, in fact, even Hertz and Marconi did not do, and millimeter waves have only again come into prominence 50 or 100 years after J.C. Bose's work.
Meanwhile, a young inventor in Italy, Marconi, also tries to generate and send these waves long distances. Meher Engineer is an expert on Bose's science. Quite often, he comes to the town hall. This is the place where Bose demonstrated the power of these magical invisible waves in 1895. Slowly, the hall becomes packed with British officers and eminent people of Calcutta. It is going to be the first attempt by any Indian scientist to demonstrate his cutting-edge work to the public.
Why would Bose want to make a public demonstration? Because one of the things that he was very big on right from the beginning was all the results of science must be in the public domain. How do you make the results of the science in the public domain? You can't do it by spinning theories. You can't do it by making mathematics because the public doesn't understand mathematics. So you have to do a visually compelling demonstration.
Bose has a plan for a compelling demonstration. He places his tiny setup of transmitter and receiver on a table. This is many times smaller than the giant equipment of Hertz. For waves, the length between two peaks or troughs is called its wavelength. Hertz's waves had a wavelength of nearly 66 centimeters.
When the wavelength becomes very large, it's very difficult to study the properties of these waves with any amount of accuracy. Bose understood all this, and in a flash of insight, he saw one way to solve all the problems, which was to miniaturize. This is what he did. This is a miniature spark gap. This generates a spark. It generates it with a very, very small amount of electric power, and it generates waves of a very small wavelength and of a single wavelength, or almost a single wavelength, which can travel in straight lines.
Bose placed the receiver 22 meters away, attaching it with a ring bell, gunpowder, and a revolver. 3 walls were separating it from the transmitter. When everything is set, he requests Sir Alexander Mackenzie, the Lieutenant General of the then British colonial government in Calcutta, to come and switch on the transmitter. Mackenzie is made to stand in such a way that he too becomes a human wall for the waves. As he switches on the transmitter, a tiny spark creates just enough sound for Mackenzie to hear. In no time, invisible waves associated with the spark reach the receiver, penetrating the body and 3 walls in between. A flicker announces their arrival at the receiver's end. As the circuit is complete, the bell starts ringing. Bang goes the pistol and the gunpowder. The experiment also marked the arrival of Bose in the international scene in radio physics.
He could send the messages by actually making a miniature spark transmitter which would send waves, and the waves would automatically fire a gun or ring a bell or burn some gunpowder. So the whole idea was that this was able to transmit information from one place to another place. That was one demonstration. The other thing is that Bose's waves could go through walls. So he was able to demonstrate that he had this powerful radiation and powerful means of communication at his hands.
Bose had produced waves of 5 millimeter length. He was the first in the world to have produced such short waves. The design of his receiver and transmitter was also very innovative. The year after this experiment, when Bose demonstrated his work in the Royal Society of London, another news was heard. Marconi had sent radio waves for 1 mile, or close to 1.5 kilometers, a few days earlier.
The difference between Marconi's work and technology's work was that Marconi's apparatus turned out to be technologically superior for sending waves large distances, i.e. across the Atlantic, which is what he did. Bose's work was no good for that. It would not have gotten that very far, but Bose's work was technologically important because he could control the properties of his waves very accurately, and he could study their scientific properties very accurately. So Marconi won out as far as communication was concerned in those days, not nowadays. Nowadays all the cell phones that you use the waves of the kind that J.C. Bose discovered.
Marconi builds a very powerful transmitter to send waves across 3,000 kilometers from Poldhu in England to Signal Hill at Newfoundland in Canada. He was attempting to send the first message in the history of wireless communication using Morse code. It was a very big challenge, economically as well as scientifically.
The experiments had involved risking at least £50,000 to achieve a result which had been declared to be impossible by some of the principal mathematicians of the time. The chief question was whether wireless waves would be stopped by the curvature of the earth. All along I had been convinced that this was not so, but some eminent men held that the roundness of the earth would prevent communication over such a great distance as across the Atlantic.
At Signal Hill in Canada, a kite is flown very high with an antenna to catch the signals even if they are very weak. From England, the signals for the letter S are sent repeatedly using Morse code. 3,000 kilometers away, Marconi listens to these signals.
In December 1901, I was able for the first time, by means of stations specially constructed for that purpose, to transmit and receive telegraphic signals right across the Atlantic Ocean, from Poldhu in Cornwall to St. John's, Newfoundland, a distance of about 1,800 miles.
It was a historic moment for the world. Not only had Marconi proved that waves could travel long distances, but also showed a way to attach a message onto it. Now, for the first time, radio waves really became messenger waves. Audion, as this bulb was known, helped radio becoming truly a mass medium. An American scientist, Lee D. Forrest, had invented it. The Audion tube helped sound to ride on high frequency waves. Spark generates waves of many frequencies. With the Audion tube, it became possible to control the frequency of the generated radio waves. Sound waves cannot travel very far on their own. Microphone converts them into a pulsating electric current. Simultaneously, an Audion tube produces a carrier wave of very high frequency. As the current from the microphone is applied on the grid of the Audion tube, it modulates it. This way, sound piggybacks on a high frequency wave traveling long distances without any loss. By this time, it becomes known that Earth's atmosphere has a layer that reflects radio waves. This was the layer that had helped Marconi's signal to travel 3,000 kilometers. Radio emerges truly as a people's medium around 1930s and 1940s.
ये आकाशवाणी दिल्ली का इंद्रप्रस्थ चैनल है। BBC लंदन है और आप सुन रहे हैं आजकल शिवानी शर्मा के साथ। स्वागत है।
Right now, while you were talking, I just learned that the Japanese are now mining Burma. This is an act that may lead the United States to war against China.
मीडियम वेव 386.3 मीटर अर्थात 819 किलोहर्ट्ज पर।
Well, I think people got hooked to radio because, of course, it brought into their homes all sorts of things which they couldn't get before. Brought into their homes dramas, it brought into their homes news much more quickly than they could get from newspapers. It brought into their homes things like soap operas, and of course it brought into their homes a lot of music, and a far wider variety of music than in those days they could ever have afforded to buy on gramophone records.
1939. Hitler announces attack on Poland.
All these regions have only Germany to thank for their cultural development.
Versuchen sollte, auf dem Weg zollpolitischer Maßnahmen Danzig wirtschaftlich zu vernichten.
British Prime Minister Chamberlain announces a war against Hitler.
In Berlin, handed the German government a final note, thinking that unless we heard from them
Radio was the
by
medium
11
that took the
o'clock,
Second World
that they were
War to
prepared
everyone's
at once
homes.
to withdraw their troops from Poland, a state of war would exist.
Oh, certainly it's changed the world in a very big way. For the discovery of radio in the first place was what led to the discovery of television. But it altered the whole way we did news. It made news much more instant than it was before. It brought everyone closer together because you could have programs from India, you could have programs from everywhere if you were in Britain. It made us very much more listening people than we were before, and it made us much better informed people than we were before.
On the eve of independence in 1947, radio was the medium that brought Nehru's famous midnight speech to the people. This was the work of science that really touched everybody's life in myriad ways.
At the stroke of the midnight hour, when the world sleeps, India will awake to life and freedom.
Advent of radio took curiosity to new heights. Rakesh Kapoor has been a ham operator for 35 years. Hams are the persons who make their own radio transmitters and connect to people all over the world. They still use Morse code to communicate within their group.
ये मैं बात कर रहा हूँ एक रशियन स्टेशन है उनसे भी मैंने ये अपना कांटेक्ट शुरू किया है और उन्होंने मुझे बताया है कि मेरे सिग्नल उनको कितने स्ट्रांग रशिया में मिल रहे हैं.
In challenging circumstances, they help re-establishing communication with the cut-off regions. Still, radio waves were set to open new areas for mankind to explore. Carl Jansky, an American electrical engineer, discovers radio sources in the sky. The discovery takes 2 to 3 decades for producing startling results, opening up a new discipline of radio astronomy. 80 kilometers from Pune, in western India, stands one of the largest radio observatories in the world, GMRT.
Karl Jansky was investigating the disturbance to radio communication, something unwanted, some noise which you hear as some hiss in your radio. And he traced a lot of it to terrestrial sources, but some of it was still unexplained. And he had the curiosity to investigate this, and he found it is coming from the center of our own galaxy. And astronomers at that time did not take this very seriously. They were used to studying stars which emit visible light, the same kind of light that our eyes are sensitive to. And this idea took several decades to sink in, that apart from the visible universe, visible to our eyes, there is an invisible universe.
These radio astronomers are able to see the universe more deeply and differently than the traditional optical astronomy. Aiming far into the sky, these telescopes reveal deep hidden secrets of the universe that are beyond human reach. They have changed our understanding of the universe.
Before radio astronomy, astronomers had this picture of individual stars like our sun, and these were gathered together in galaxies with a lot of empty space in between, and galaxies filling the universe, which again a lot of empty space in between. What radio astronomy taught us is, first of all, the space is not empty. It's full of energetic particles and magnetic fields, and full of hydrogen, which is the basic building block, being the simplest chemical element. The individual stars themselves would end their life in violent explosions which emit radio waves. I think after radio astronomy and the other forms of astronomy like X-rays and gamma rays which followed, we now realize that the universe is full of violent events, explosions, collapse, release of tremendous amount of energy, and so on.
Today we know that radio waves are a part of the electromagnetic spectrum. These waves are grouped on the basis of their frequencies. There are many frequencies that penetrate the atmosphere. Television signals piggyback on some of these waves to reach satellites in space. Satellites amplify these waves and beam them back to the ground stations on Earth. Today, apart from research, radio waves are also used in the kitchen, in medical sciences, in weather studies, and in many other areas. Maybe someday, these waves will help us reach out to another civilization in far deep corners of the universe.